Right, so we're looking at integration. Remember last week we did substitution. Right, so we made usually the variable u, doesn't always have to be. Usually it is. Okay, so make a substitution u and we replace it to manipulate the function because we can't integrate it, or part of a function that we can't integrate, and we turn it into something that we can integrate. Right, so obviously one of the applications of integration is to find the area of underneath the curve and the axis between two endpoints. So the area bounded by the curve y equals x outside of the square root of 1 minus x squared, x-axis in the lines x equals 0 and x equals 1, and you will be told it's a substitution, okay, in this course. So the first thing I like to do is use that. So we differentiate, I do a d, differentiate u with respect to x. Okay, so negative 2x dx. So we need this, we need the area, so we're integrating at the moment from 1 to 0 of x square root of 1 take away x squared dx. Okay, so that's what we need to integrate for our area. Right, so I've got negative 2, and I've got negative 2x dx, and I've got here an x dx. So I can place this part with you underneath the square root, but I need to do a bit more so I can get x dx. So what I'll do is get that subject, so it'll be du, so negative du over 2 is equal to x dx. So I'll write what I need to replace, and then I'll dump that in there. Okay, so the integrand, so one more thing we need to do, because we're changing the variables from x to u, we also need to change the endpoint of integration. Right, so when x is 1, put it straight in substitution, the u is going to be 1 take away 1 squared, so 1 take away 1, which is 0. And x is 0, so u is going to be 1. Okay, so notice that the endpoints have swapped. Alright, so we don't swap it back, we leave it as it is. Okay, but what we're going to do is we're going to take the absolute value because we're calculating the area. Okay, so it's going to be, so we've got negative a half right out the very front, integral from 0 to 1. The x dx is getting replaced by du over 2, so it's a half already out the front, and then the square root of 1 take away x squared, becomes square root of u du. And then I'm going to put absolute value signs there. I may or may not need it. See how my answer is looking. Right, so negative a half. So it's square root of u. Okay, so it becomes a 2 u to the 3 over 2 over 3 from 0 to 1. Okay, now because I've got 0 to 1, I'm not going to bother changing it back to square root form, okay, because I'm going to know that u to the power of anything is going to be, 0 to the power of anything is 0, and 1 to the power of anything is going to be 1, okay. So it's going to be negative a half, so I'm just bringing that 2/3 constant out the front. And then I've got really 0 take away 1. Okay, and then we can see here I don't actually need the absolute value. Once I do all the arithmetic, it's going to cancel it anyway. Alright, so I'm just putting there just to be observant that yes, I might need to do that. Alright, but really I don't need to. So I'll cancel that. So it'll be a negative a third times negative 1. It's the third unit squared for the area. Okay. Right, so we want to find the area bounded by that curve, the x-axis and the line x equals square root of 2 and the x equals square root of 5. Okay, so this one I haven't given you a substitution because I want to show you that from looking at that you should be able to tell me what you're going to make substitution. Okay, so what would substitution be?
X squared take away 1.
Good. Okay, so x squared. Because I'm looking at that, I'll know if I differentiate x squared, I'll get x. Alright, so I'm going to make that my u, so when I differentiate, I'm going to get that lower power of x, what I need. Okay, so du is going to be 2x dx. Okay, so that's two lines of working in one. Alright, so once we're comfortable with that, we can do that. Okay, so we're really doing y equals x dx over the square root of all that. So I need x dx, so I need to rearrange so that I can make the substitution. Okay, and then I need to do that. So x is the square root of 2. The u is going to be 2 take away 1. Let's do the manipulation. X equals root 5, so u is going to be 5 take away 1. Okay, so that's the highest one. Okay, that's further to the right, so that'll be on the top of the integrand. Right, so that means the 4 is going to be on top of the integrand. Okay, so it's going to be, so replace x dx with what I've got over here. So it's going to be a half integral from 4 to 1 of du over the square root u. Just for convenience, I'm just going to write a negative power so I can integrate. So it'll be u to the half over a half, so it'll be 2 root u. Okay, so this 2 is the common factor in both the expressions in here. So we're not going to factor those out, it's just going to cancel. Okay, so it's really just the square root of 4, take away the square root of 1. Units squared. Right, so that covers now definite integrals. So exercises 310 and 311 in the integration chapter.